An EEG, or an electroencephalogram, is basically a technique that's used in the clinic to get your brain waves. It's really expensive, and you have to be inside of the hospital to get it. What we're trying to do is create a pocket version of it that you can go to a drugstore and buy for your activities of daily living, and you can record your own brainwaves. This is a tiny device, and it's got a couple of electrodes, right? And these electrodes will go on your head, right? So just around your head like this. The idea of this is we can put this into a baseball hat or a bike helmet or something that's out of the way. It's connected to our little device. I think this project was really exciting to me because it spoke to me in terms of what area I want to go into, specifically using embedded systems and using electrical engineering to help people in health and daily living, to improve the quality of health of people. My role was the lead engineer of this project. So I spent a lot of the time, I collaborated with my team, and we created our design requirements and also our design itself for our printed circuit board.
So Manuel was in charge of, one, locating and finding an analog front-end chip. Let me explain what that is. So our board takes in an analog signal. Obviously, the electrical impulse is produced by your brain. And for our microcontroller to understand those signals, they have to be converted from analog to a digital signal. And so the analog front-end chip is able to convert those signals there.
My role on this project was the communications lead, so I was in charge of communicating our hardware technicalities and requirements to the teams in CS and biomedical, making sure that the components that they were bringing to the table were going to interface well with our board. I was in charge of coordinating meetings. I sent out lots of emails. I gave routine updates to the team to let them know where we were. For the computer science side of things, I was specifically in charge of our Bluetooth module and making sure that it would simplify the software handshake and streamline data visualization, making sure that the communication protocol would interface well between our teams.
I was the safety lead for the project. So I was mostly in charge of finding some of the components we used on our board, and as well as finding safety procedures that needed to be carried out in our project and certain components on the board that help keep the board as well as the user safe.
So it's the first time that we were presented with the opportunity to actually take a design all the way up to a physical prototype. So it was really rewarding to go through that process and face those challenges and then learn to communicate with so many other people just within our department and then the other department as well. My favorite part of work on this was for sure the assembly. To see the schematics kind of come to life into this physical solution was very rewarding, and getting to use our soldering skills was really fun as well. I think that our team got very lucky. I can't say I knew Ethan and Abhinav and Manuel the best before this project, but coming together, we did mesh very well from the very beginning. The way that we delegated tasks, I think, was very smart. Everybody was very willing to do the work and wanted to do it to the best of their ability and then come back, and communication was very open, which I think is key to the teamwork and making sure that there's not any technical disagreements and just making sure everything moves straightforward.
One big hurdle I would say that we came across was initial communication with the microcontroller on our board. Once we had it put on there, we thought the board was ready to go, at least to be able to communicate with the microcontroller, and we just couldn't. And so lots of time was put in to figure out what was going on with that, but it took us a couple weeks to figure that out. So it was a pretty substantial hurdle for us.
I would say that this was a really good experience. I think that it kind of pushes you to grow, to take some initiative and to push some boundaries that we haven't been asked to do before. It kind of helps build confidence, and it also helps with communication skills and getting to know the people you're working with and how to align visions as well, which I think will be really applicable in the future.
I really much enjoyed this experience because it forced me to be collaborative with my engineering skills, and I feel like there's not a lot of places you can find that, right? And so I think these types of project-based assessments were the best way for me to learn and also prove what I learned the last 4 years can actually be implemented into a real-world thing.